Hey everyone, and welcome back to the channel. Today, we are diving into the world of infrastructure as a code, and we are going to completely transform how you manage your Proxmox virtual machines. If you ever found yourself clicking through Proxmox web interface to create new virtual machine, setting up the CPU, RAM, network, and disk, you know how repetitive and time-consuming that can be, especially if you need to create 10, 20, or even 50 identical virtual machines. That's where Terraform comes in. It's a powerful open source tool that allows us to define our infrastructure in code. You describe the final state you want, a virtual machine with this much RAM, this many cores, and disk size, and Terraform handles all those steps to get there. So the key benefits are: first, consistency. You eliminate human error. Every virtual machine you create from your code will be identical, ensuring a consistent and reliable environment. Second, repeatability. Need to spin up a new test environment? With Terraform, it's as easy and simple as running a single command. The entire process is repeatable and reliable. Third, version control. Your infrastructure is now a code base. You can store your configuration files in Git repository, track changes, and collaborate with others, just like you would with application code. This makes it easy to audit changes and roll back if something goes wrong. Last but not least, efficiency. Instead of long manual process, you can provision complex infrastructure in minutes with a single command. So are you ready to stop clicking and start coding? Great. Let's lay out our plan. We will start by installing Terraform on our machine. Then we will talk briefly about different Terraform providers and introduce the one I will be using for Proxmox. Finally, I will break down the Terraform code, explain exactly what each part does so we can customize it for your own needs. And finally, we will provision virtual machines using our Terraform code. You will find the code and all the resources you need in the description below. The best place to start is always the official documentation. Quick search for install Terraform will lead us directly to the HashiCorp website. On their installation page, you can see they provide detailed instruction for a wide range of operating systems: Windows, macOS, and different flavors of Linux. For macOS users, the simplest method is to use Homebrew. You would simply run brew install Terraform. For Windows, you have similar package manager called Chocolatey, which makes the process very easy. With a single command choco install Terraform, you will have Terraform on your Windows as well. Under the Linux section, you will see a drop-down menu with instructions for different distributions like Fedora, CentOS, and Amazon Linux. If you remember, in previous video, we set up an Ubuntu cloud image. So I'm going to use that virtual machine to install Terraform. I will choose Ubuntu here. I'm going to SSH into Ubuntu virtual machine and simply follow the official instructions provided by HashiCorp. The process involves a few commands. First, we will make sure our system is up to date and has all the necessary packages to handle GPG keys and software repositories. Next, we will need to install HashiCorp GPG key. This key is used to verify that the software we downloaded is legit and comes directly from HashiCorp. For an extra layer of security, you can verify the fingerprint of the GPG key to ensure you have the correct one. The documentation provides the expected fingerprint. After confirming the key, next step is to add the official HashiCorp repository to our system. Now that the repository is added, we need to update our local package index to include the new packages. And finally, we can install Terraform just like any other package with apt install command. To confirm if Terraform was installed, we can simply run Terraform version. As you can see, Terraform is successfully installed. Now we are ready for the next step. Now that the Terraform is installed, the next thing we need is a provider. Provider is a plugin that allows Terraform to interact with a specific platform's API, in this case Proxmox. If you search the Terraform registry for Proxmox, you will likely see two main options at the top: Telmate Proxmox and BPG Proxmox. At first glance, you might be tempted to choose the Telmate provider. It has higher number of downloads and a lot of stars on its GitHub repository, suggesting its more popular choice. While Telmate has a higher star count, BPG provides support for more advanced Proxmox features like API token authentication, which is much more secure method than using username and password. Also, it provides software-defined networking that allows you to manage Proxmox built-in networking features in code. I also tried Telmate first because it was the most popular one, but I ran into several issues like inconsistent behavior with Cloud Init and in some cases VM not provisioning the way I expected. After some frustration, I switched to BPG and it just works much more smoothly. That's why I recommend it, especially if you're starting fresh. Now let's dive into the code and see how we put all those into practice. Now comes the fun part. Let's start writing our code. I have created a new file named main.tf, and before we go any further, a quick tip for anyone using VS Code is to get the beautiful syntax highlighting you see here, as well as features like code completion and formatting. For this, make sure to install HashiCorp Terraform extension from the VS Code marketplace. It's an official extension and makes writing Terraform much better experience. Now the first thing we need to do in any Terraform configuration is to specify our provider requirements. This tells Terraform which plugin it needs to download and use when we run our code. The first block of code we are looking at is the Terraform block code. And inside of it we have required providers. This is the most important part of our setup because it tells Terraform exactly which plugins to download. Source equals BGP Proxmox. This line is Terraform address book. It tells Terraform precisely where to find the provider plugin we want to use. In this case, BGP Proxmox provider from the public Terraform registry. Next is a version, and here I specified the version that is greater or equals to 0.80.0. This constraint ensures that our code will never install a version older than the one we have specified. And actually, this prevents us from running into the compatibility issues with outdated providers. Okay, with our provider requirements defined, the next logical step is to tell Terraform how to connect to our Proxmox environment. This is done with the provider block. Endpoint equals. Here is the address of your Proxmox API. This is the URL where Terraform will send its commands. You need to replace the IP address with the IP address of your own Proxmox host. Make sure to include HTTPS and the standard API port, which is 8006. API token equals to. This is how we authenticate with Proxmox. We are using an API token, which is the recommended and most secure way. An API token is a unique key that you can generate in the Proxmox UI for a specific user. It's much better practice than using password because you can create separate tokens for different purposes and revoke them individually without affecting the user's main password. You should never hardcode sensitive information like an API token directly into your Terraform file like this. I'm doing it for demonstration, but in real project, you should always use environment variables or a separate tf-vars file to keep this information secure. I'm not hiding this token in this video because by the time you're watching this, I will already have deleted it. Also, the Proxmox server I'm using here is on private network and it's not accessible from the internet. Now that we know what the API token in our code is for, let's walk through how we can generate one in Proxmox web interface. This is exact process I followed to create token we are using in our example code. First, navigate to Data Center menu in the left sidebar. From there, select Permissions and click on API Tokens tab. Next, click Add button. A new window will pop up with some options. We will give our token a name like Terraform 1 because I already have token generated with the name Terraform that I already pasted in my code. We will uncheck the privilege separation box to keep things simple and then click Add once more. And that's it. Proxmox has generated your token ID and the token secret. The secret is critically important. It will only be shown to you this one time. Make sure to write it down and store it in a secure place. With our provider configured, next comes the resource block. This is where we will tell Terraform exactly what we want to create. In our case, a new virtual machine. Name equals to simple cloned VM. This is the friendly human-readable name of your virtual machine. This is the name you will see in the Proxmox web interface after the VM is created. Node name. This is crucial setting in a multi-node cluster. It specifies which physical Proxmox host or node the new virtual machine will be created on. You will need to replace this with the name of your own Proxmox node. VM ID. Every virtual machine in Proxmox needs a unique ID. You can either let Proxmox assign one automatically, or as we are doing here, you can specify one yourself. Explicitly setting the VM ID gives you more control and makes your configuration more predictable. With the basic VM details in place, we now need to tell Terraform how to build the VM. A core feature of this provider is its ability to clone from a template, which saves huge amount of time. If you remember from our previous video, we created a Cloud Init Ubuntu template with VM ID 8002. And that's the one we will be using here. This template should have the operating system and any base software you need pre-configured. You need to change this ID to match your own template's ID. Full equals true. This setting is very important. It tells Terraform to perform a full clone. This means it will create a completely independent copy. The alternative is a linked clone, which shares the original disk image and can be more complex to manage. A full clone is generally the best and most reliable option for most use cases. The CPU block is straightforward. Here we are simply telling our new virtual machine to have 2 virtual CPU cores. The memory block is where we set the amount of RAM for our virtual machine. The dedicated equals to 2045 simply means that Proxmox will allocate 2 GB of RAM. I have commented out the disk block here because for this project we will be using the disk setting and size that are already configured in our Ubuntu Cloud template. This is one of the big advantages of using well-prepared template. However, if you want to, you could just uncomment this block and use it to override the template disk settings. For example, you could give the virtual machine larger disk or add brand new disk on a different data store. With our memory configured, let's set up the networking for our virtual machine. The network device block is where we configure how our virtual machine connects to the network. Bridge equals VM bridge 0. This is crucial setting. In Proxmox, a bridge acts like a virtual network switch. To find the correct bridge name for your own environment, go to your Proxmox web interface, click on your node name, then go to System tab, and finally click on Network. For my setup, the name of this bridge is VM bridge 0, which is what I am using in the code. The QEMU guest agent is a service that runs inside your virtual machine and allows the Proxmox host to communicate with it. It can be used to get information like virtual machine's IP address or shut down VM gracefully. Enabled equals false means that I have set it to disable. Terraform will wait for the guest agent to come online before the Terraform apply command finishes, which can take a lot of extra time. By setting this to false, you can provision the VM much faster and not have to wait for the agent to be fully online. The final piece of our VM configuration is the initialization block. This is where the magic of Cloud Init happens, allowing us to configure the operating system inside the VM on its first boot. This block tells Proxmox what initial settings to inject into the cloned Ubuntu template. We are specifically focusing on the network setup here. By setting the address to DHCP, we are instructing the VM to automatically request an IP address from your network's DHCP server when it starts up. This is the easiest way to get your virtual machine online. If you needed a specific unchanged IP address, you could replace DHCP with static configuration, but for most lab setups, DHCP is much more convenient. Alright, we have written the infrastructure definition in our main TF file. Now it's time to bring that configuration to life. We are working inside our Cloud Init Ubuntu virtual machine, where we installed the Terraform client earlier. The first thing we need to do is to set up project directory. I'm creating a new folder named Terraform and pasting the Terraform code from Visual Studio Code into main TF file. This single file contains the entire blueprint for our new virtual machine. The very first command we run is terraform init. This command is crucial. It initializes our working directory. It scans the main TF file for any required providers, like the BPG Proxmox provider, and automatically downloads the necessary plugin code. It's setting up the environment so Terraform knows exactly how to communicate with our Proxmox host. You can see it quickly found and installed the Proxmox provider. Next is the critical safety check, Terraform plan. This command is non-destructive. It doesn't make any changes yet, but it analyzes our current Terraform configuration and compares it against the existing state of the infrastructure on Proxmox. It then generates a detailed execution plan showing exactly what actions it will take. For us, the output confirms the plan. 1 to add. It's going to create the virtual machine exactly as we defined it. Usually, this step is your chance to review everything before committing. Next comes the Terraform apply. This command executes the plan we just reviewed. Terraform asks for confirmation. We type yes and hit enter. As soon as process starts, you can already see the VM, which we named Simple Clone VM, instantly appear in Proxmox UI. Terraform is now talking to the Proxmox API, cloning the template, setting up the hostname, configuring the DHCP address, and most importantly, injecting the Cloud Init configuration. Since provisioning a full VM takes time, I will just speed this part a bit. And there we have it. The apply is complete and the VM is fully provisioned. I can immediately SSH into the new virtual machine using the SSH key. This key was injected automatically without any manual password entry on console configuration. Our VM is live, secure and ready to go. All thanks to single well-defined Terraform script. I hope this helped you with your project. If you enjoyed it, please hit the like button and consider subscribing so you don't miss future videos. If you have any questions, drop them in the comment section, or if there is a specific topic you want me to cover next, let me know that too. Thanks for watching and I will see you in the next one.